Section 7 of the Science History of the Universe, Volume 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Science History of the Universe, Volume 2, edited by Francis Rolt-Wheeler. Geology, Chapter 4, Werner and Hutton, Part 1. With the freeing of geological study from the trammels of ecclesiasticism arose a rejuvenating significance in the determined spirit that prevailed to discountenance speculation and to seek untiringly in the field and the laboratories after new observations, new truths. Interest was directed, in the first place, toward the investigation and description of the accessible parts of the earth's crust. The composition and arrangement of the strata were studied with enthusiasm. The bolder inquirers ventured into wild recesses of mountain chains and climbed snowy peaks, whose difficulties had hitherto been thought insurmountable. Travelers explored the uninhabited plains of Siberia, the remote mountain ranges of Asia and America, and brought home with them new scientific material and observations of the highest importance for comparative research. Together with this arose the realization of the value of understanding the works of the geologists of the past. For the first time, a history of geology became possible. As Sir Archibald Geikie said, in no department of natural knowledge is the adoption of this historical method more necessary and useful than it is in geology. The subjects with which that branch of science deals are, for the most part, not susceptible of mathematical treatment. The conclusions formed in regard to them, being often necessarily incapable of rigid demonstration, must rest on a balance of probabilities. There is thus room for some difference of opinion both as to facts and the interpretation of them. Deductions and inferences which are generally accepted in one age may be rejected in the next. This element of uncertainty has tended to encourage speculation. Moreover, the subjects of investigation are themselves often calculated powerfully to excite the imagination. Quote, "The story of this earth since it became a habitable globe, the evolution of its continents, the birth and degradation of its mountains, the marvelous procession of plants and animals which, since the beginning of time, has passed over its surface, these and 1,000 cognate themes with which geology deals have attracted numbers of readers and workers to its pale, have kindled much general interest and awakened not a little enthusiasm. But the records from which the chronicle of events must be compiled are sadly deficient and fragmentary. The deductions which they suggest ought frequently to be held in suspense from want of evidence. Yet with a certain class of minds fancy comes in to supply the place of facts that fail. And thus geology has been encumbered with many hypotheses and theories which, plausible as they might seem at the time of their promulgation, have one by one been dissipated before the advance of fuller and more accurate knowledge. Yet before their overthrow it may often be hard to separate the actual ascertained core of fact within them from the mass of erroneous interpretation and unfounded inference that forms most of their substance." End quote. The modern period begins with the advent of a man who bulks far more largely in the history of geology than any of those with whom up to the present we have been concerned. A man who wielded an enormous authority over the mineralogy and geology of his day. Through the loyal devotion of his pupils, he was elevated even in his lifetime to the position of a kind of scientific pope, whose decisions were final on any subject regarding which he chose to pronounce them. During the last quarter of the 18th century, by far the most notable figure in the ranks of those who cultivated the study of minerals and rocks was unquestionably Abraham Gottlob Werner, 1749 to 1817. The vast influence which this man wielded arose mainly from his personal gifts and character, and especially from the overmastering power he had of impressing his opinions upon the conviction of his hearers. Werner was born in 1749 at Werner, in Upper Lapatia, of a family which had long been interested in the iron industry. Thus from infancy he was in intimate contact with people interested in topics akin to geology. He early became interested in mineralogy, and his tendency in this direction was encouraged by his father. The latter desired his assistance in the smelting houses at Werner, but the boy's ambition to devote himself to minerals had taken too deep root, and he decided to go to the riding academy at Freiburg. He was a most ardent student, and all his spare moments were spent in neighboring mines. In 1771 he went to the University of Leipzig, where he prosecuted the study of law for 2 years, but eventually returned to his first love, mineralogy. When only 25 years of age he published a book on minerals, then a wonder of arrangement, largely as a result of which he was appointed to the post of professor of mineralogy in the School of Mines at Freiburg, where he had formerly studied. His manner of discourse also was so attractive and stimulating that he riveted the attention of his pupils, incited them to pursue the studies that he loved, and fired them with a desire to apply his methods. Ostensibly he had to teach mineralogy, a science which in ordinary hands can hardly be said to evoke enthusiasm. But Werner's mineralogy embraced the whole of nature, the whole of human history, the whole interests and pursuits and tendencies of mankind. From a few pieces of stone, placed almost at random on the table before him, he would launch out into an exposition of the influence of minerals and rocks upon the geography and topography of the earth's surface. He would contrast the mountainous scenery of the granites and schists with the tamer landscapes of the sandstones and limestones. Tracing the limits of these contrasts of surface over the area of Europe, he would dwell on their influence upon the grouping and characteristics of the nations. He would connect, in this way, his specimens with the migration of races, the spread of languages, the progress of civilization. He would show how the development of the arts and industries of life had been guided by the distribution of minerals, how campaigns, battles, and military strategy as a whole had been dependent on the same course. The artist, the politician, the historian, the physician, the warrior were all taught that a knowledge of mineralogy would help them to success in their several pursuits. It seemed as if the most efficient training for the affairs of life were obtainable only at the mining school of Freiburg. The first feature of his grasp, distinguishable in every part of his life and work, was his overmastering sense of orderliness and method. When Werner entered upon his mineralogical studies, the science of minerals was an extraordinary chaos of detached observations and unconnected pieces of knowledge. But his very first essay began to put it into order, and by degrees he introduced into it a definite methodical treatment, doing for it very much what Linnaeus had done some years before for botany. Like that great naturalist, he had to invent a language to express with precision the characters which he wished to denote, so that mineralogists everywhere could recognize them. For this purpose he employed his mother tongue and devised a terminology which, though artificial and cumbrous, was undoubtedly of great service for a time. Uncouth in German, it became almost barbarous when translated into other languages. What would the modern English-speaking student think of a teacher who taught him, as definite characters, that a mineral could be distinguished as hard or semi-hard, soft or very soft, as very cold, cold, pretty cold, or rather cold, as fortification-wise bent, as indeterminate curved lamellar, as common angulo-granular, or as not particularly difficultly frangible? Werner arranged the external characters of minerals in so methodical a way that they could readily be applied in the practical determination of species. Yet strangely enough he neglected the most important of them all, that of crystalline form. From the individual minerals he proceeded to the consideration of their distribution and the character and origin of the different rocks in which they occur. To this branch of inquiry he gave the name of geognosy, or knowledge of the earth, and he defined it as the science which reveals in a methodical order the terrestrial globe as a whole, and more particularly the layers of mineral matter whereof it consists, informing as to the position and relations of these layers to each other, and enabling the formation of some idea of their origin. The term geology had not yet come into use, nor would either Werner or any of his followers have adopted it as a synonym for the geognosy of the Freiburg school. They prided themselves on their close adherence to fact as opposed to theory. They boasted of the minuteness and precision of their master's system, and contrasted the positive results to which it led with what they regarded as the vague conclusions and unsupported or idle speculations of other writers. Werner arranged the crust of the earth into a series of formations, which he labeled and described with the same precision that he applied to the minerals in his cabinet. But never in the history of science did a stranger hallucination arise than that of Werner and his school when they supposed themselves to discard theory and build on a foundation of accurately ascertained fact. Never was a system devised in which theory was more rampant, theory, too, unsupported by observation, and, as is now known, utterly erroneous. One of the fundamental postulates of the Wernerian doctrines was the existence of what were termed universal formations. When he elaborated his system, Werner had never been out of Saxony and the immediate adjacent regions. His practical knowledge of the earth was, therefore, confined to what he could see there, and so little was then known of the geological structure of the globe as a whole that he could not add much to his acquaintance with the subject by reading what had been observed by others, though there can be little doubt that he stood greatly indebted to Lehmann and Fuchsel. With this slender stock of acquirement he adopted the old idea that the whole globe had once been surrounded with an ocean of water, at least as deep as the mountains were high, and he believed that from this ocean there were deposited by chemical precipitation the solid rocks which now form most of the dry land. He taught that these original formations were universal, extending round the whole globe, though not without interruption, and that they followed each other in a certain order. Werner affirmed that the first formed rocks were entirely of chemical origin, and he called them primitive, including in them granite, which was the oldest, gneiss, mica slate, clay slate, serpentine, basalt, porphyry, and concluding with syenite as the youngest. Succeeding these came what he afterwards separated as the transition rocks, consisting chiefly of chemical productions, greywack slate, and limestone, but comprising the earliest mechanical depositions and indicating the gradual lowering of the level of the universal ocean. Still newer, and occupying, on the whole, lower positions, marking the continued retirement of the waters, were the Floetz rocks, composed partly of chemical, but chiefly of mechanical, sediments, and including sandstone, limestone, gypsum, rock salt, coal, basalt, obsidian, porphyry, and other rocks. Latest of all came the alluvial series, consisting of recent loams, clays, sands, gravels, sinters, and peat. This system was not put forward tentatively as a suggestion toward better comprehension of the history of the earth. It was announced dogmatically as a body of ascertained truth about which there could be no further doubt or dispute. Quote, "In recapitulating the state of our present knowledge," end quote, Werner declares with his characteristic emphasis, quote, "It is obvious that we know with certainty that the Floetz and primitive mountains have been produced by a series of precipitations and depositions formed in succession from water which covered the globe. We are also certain that the fossils which constitute the beds and strata of mountains were dissolved in this universal water and were precipitated from it. Consequently, the metals and minerals found in primitive rocks and in the beds of Floetz mountains were also contained in this universal solvent and were formed from it by precipitation. We are still further certain that at different periods different fossils have been formed from it. At one time earthy, at another metallic minerals, at a third time some other fossils. We know, too, from the position of these fossils, one above another, to determine with the utmost precision which are the oldest and which are the newest precipitates. We are also convinced that the solid mass of our globe has been produced by a series of precipitations formed in succession, in the humid way, that the pressure of the materials thus accumulated was not the same throughout the whole, and that this difference of pressure and several other concurring causes have produced rents in the substance of the earth, chiefly in the most elevated parts of its surface. We are also persuaded that the precipitates taking place from the universal water must have entered into the open fissures which the water covered. We know, moreover, for certain that veins bear all the marks of fissures formed at different times, and, by the causes which have been assigned for their formation, that the mass of veins is absolutely of the same nature as the beds and strata of the mountains, and that the nature of the masses differs only in the locality of the cavity where they occur. In fact, the solution contained in its great reservoir, that excavation which held the universal water, was necessarily subjected to a variety of motion, while that part of it which was confined to the fissures was undisturbed and deposited in a state of tranquillity its precipitate." End quote. It would be difficult to cite from any other modern scientific treatise a series of consecutive sentences containing a larger number of dogmatic assertions, of which almost every one is contradicted by the most elementary facts of observation. The habit of confident affirmation seems to have blinded Werner to the palpable absurdity of some of his statements. For example, the theory of a universal, primeval ocean occupying an excavation that was so deep that it overtopped the highest mountains was superficially most ridiculous. If this ocean covered the entire globe, where was the excavation, and how did this deep ocean disappear? It may be interesting to know how Werner explained this natural question, but none of his writings satisfactorily answer it. In one place he thinks it possible that, quote, "one of the celestial bodies which sometimes approach near to the earth may have been able to withdraw a portion of our atmosphere and of our ocean." End quote. But if once the waters were abstracted, how were they to be brought back again so as to cover all the hills on which his highest flowets formations were deposited? One might have thought that, having disposed of the universal ocean, even in this rather peremptory fashion, the Wernerians would have been in no hurry to call it back again and set the same stupendous and inexplicable machinery once more going, but the exigencies of their theory left them no choice. Having determined, as an incontrovertible fact, that certain rocks had been deposited as chemical precipitates in a definite order from a universal ocean, when these philosophers, as their knowledge of nature increased, found that some of these so-called precipitates occurred out of their due sequence and at much higher altitudes than had been supposed, they were compelled to bring back the universal ocean and make it rise high over hills from which it had already receded. Not only had they to call up the vasty deep, but they had to endow it with rapid and even tumultuous movement as it swept upward over forest-clothed lands. Having raised it as high as their so-called flowets formations extended, and having allowed its waters to settle and deposit precipitates of basalt and greenstone, they had to hurry it away again to the unknown regions where it still remains. So early as 1768, before Werner had commenced his mineralogical studies, Raspe had truly characterized the basalts of Hesse as of igneous origin. Arduino had pointed out numerous varieties of trap rock in the Vincentine as analogous to volcanic products and as distinctly referable to ancient submarine eruptions. Desmarest had, in company with Fortis, examined the Vincentine in 1766 and confirmed Arduino's views. In 1772 Banks, Solander, and Troyle compared the columnar basalt of Hecla with that of the Hebrides. Coligny, in 1774, recognized the true nature of the igneous rocks on the Rhine between Andernach and Bonn. In 1775 Guettard visited the Vivarais and established the relation of basaltic currents to lavas. Lastly, in 1779, Faujas published his description of the volcanoes of the Vivarais and Velay, and showed how the streams of basalt had poured out from craters which still remain in a perfect state. End of section 7. Recording by Grognor.